Alright, this video is a continuation of the last video. Once again, we're still working with product and quotient rule. This is going to be the longer example that I promised you guys, the one that you may see something similar to on an exam, especially if it's a harder exam. There's going to be a combination of product and quotient rule, as well as some of the earlier rules I described in my previous videos. So let's go ahead and get started. So we're going to start with the function, and the function is going to be f of x is, let me make that a little bit bigger for you guys, f of x is equal to, we're going to have x squared over the natural log of x plus 9x e to the x plus x squared plus 5x, x squared plus 5x minus 2 all over x cubed plus x. So, as you can see, this function is going to be really involved. We have three separate terms here. Now, if we look at this function, we go, okay, we have a function here divided by a function. Then we have a function here multiplied by another function. Then we have another function here divided by another function. So what we're going to have to do, the good news is we see that there are plus signs in between. So if you recall from my last video, the derivative of a function that has elements summed together is nothing more than the derivative of each element summed together. So what I mean is if I take the derivative of this entire equation, it's simply going to be equal to the derivative of this plus the derivative of this plus the derivative of this. So to kind of make that more clear, I'm going to make a few substitutions here. So let's go ahead and say a is equal to x squared over the natural log of x. Let's go ahead and make b be equal to 9x e to the x. And let's go ahead and make c equal to x squared plus 5x minus 2 all over x cubed plus 3. Or plus x, I'm sorry. Now, doing these substitutions, if I take these and plug them back into here, our equation simply reduces to f of x equals a plus b plus c. Now, you can do the substitution method if you have a longer problem like this. It actually makes it very easy for you. So it's a lot easier, in my opinion, when you look at a function to take the derivative of when it looks like this versus when it looks like this. So we know that the derivative, like I said before, so f prime of x is equal to the derivative, so I'm going to do a plus b plus c, and the derivative of a plus b plus c. And we know from what I said before that this is equivalent to of x equals a prime plus b prime plus c prime. All that means is that the derivative of each one of these, the derivative of this entire expression is equal to the derivative of each element summed together, which is what I said before. Take special note of this. This is true only when you're adding them together. Now that doesn't mean that I can do, like I said before, derivative of this divided by derivative of this. No. All that means is that when I take the derivative of this term, I can add it to the derivative of this term and add it to the derivative of this term. So this kind of makes our life a little bit easier. So I'm going to go ahead and erase the board to give us a little bit more room, and I'm going to rewrite that function at the bottom. So we have f prime of x is equal to a prime plus b prime plus c prime. And I'll go ahead and write the original equation again. So we have f of x equals x squared over natural log of x plus 9x e to the x plus x squared plus 5x minus 2 all over x cubed plus x. And I'll move this plus sign over here. And just in case you guys forget, remember that term that we called A, this term we called B, and this term we called C. So now, if we can just find the derivative of each one of these separately, we have our answer. So this makes the job a little bit easier now. So let's go ahead and start with A. So we know that A is equal to x squared over the natural log of x. And we know that this is a function divided by a function, so we have to use our quotient rule. So if you guys remember, the quotient rule is equal to f prime g minus f g prime all divided by g squared. And that's equal to a prime. So if we go ahead and label x squared as f and natural log of x is g, we can solve for that just like anything else. So we have f equals x squared. We take the derivative, so f prime is going to be equal to 2x, simple power rule. We have g equals the natural log of x. And we have g prime, simple memorization rule, is equal to 1 over x. And then, obviously, g squared is going to be g squared, which equals natural log of x all squared. We have everything now, so now we can say that a prime, which I will write here, is equal to f prime g, which is 2x, times the natural log of x, minus f minus x squared times g prime times 1 over x, all over g squared, natural log of x squared. Now, obviously, if you guys look here, when you multiply this out, you'll get x squared divided by x. So that simply just becomes x. So we can simplify this whole term just to be x. So now we have a prime. We have one of these equations up here. So I'm going to go ahead and write this off to the side here. We have that a prime is equal to 2x, natural log of x, minus x, all over natural log of x squared. Alright, so now all we have to do is determine b prime and c prime, and we'll be golden. So let's go ahead and do that. So I'm going to go ahead and erase this here. And we're going to go ahead and look at b now. So we have this b term where we say b is equal to 9x e to the x. We look at it and we say, oh look, it's two functions multiplied together. That's our product rule. And if you remember, we said our product rule is equal to f prime g plus f g prime. So I'm going to go ahead and label this function f, this function g, and we're going to go ahead and solve for everything else. So we say f is equal to 9x, g is equal to e to the x, f prime, simple derivative, is just equal to 9. Here we know the derivative of e to the x is itself e to the x. And we have everything, we just plug it back in now. So now we can write that b prime is equal to f prime 9 times g e to the x plus f 9x g prime, which is just e to the x. So b prime is simple enough. After all these examples, you may come to the conclusion that doing the product rule is a lot easier than the quotient rule, and a lot of times it is. So now we have b prime. So b prime is equal to 9 e to the x plus 9x e to the x. Now all we have to do is determine c prime, add them together, and we have our final answer. Now, although this process seems really tedious, when you get really good at these, this will become second nature, and you can do a problem like this in seriously 5-6 minutes. Easy. So the last thing we have to do is determine c prime. So we know that c is equal to x squared plus 5x minus 2 all divided by x cubed plus x. So I'm going to go ahead and I'm just going to start right here because rewriting it would take up a lot of space. So I'm going to go ahead and label the top function f and the bottom function g. We see that it's two functions divided by each other, so we need the quotient rule. So using the quotient rule, we know that c prime will be equal to f prime g minus f g prime all divided by g squared. Then, thank you Jesus for that one, what we're going to do is we're going to label each function. So we have f equals x squared plus 5x minus 2. We're going to have f prime be equal to the derivative of that. This is very simple. Equal to 2x plus 5, and then the derivative of negative 2 is just 0. So we just have f prime is equal to 2x plus 5. We have g equal to x cubed plus x. We're going to have g prime be equal to, simple power rules again, 3x squared. Derivative of x is simply 1 plus 1. And we know that g squared is going to be equal to x cubed plus x squared. We see. So once we do that, we can just plug everything back into our function. So we will have the final answer being, and I'm just going to write this here, c prime equals f, which is x squared plus 5x minus 2. F prime, I'm sorry, it should be f prime. So f prime, which is 2x plus 5, times g, which we say is x cubed plus x, and then minus f g prime, so it's going to be minus f, which we say is x squared plus 5x minus 2, put that in parentheses, times g prime, which you said was 3x squared, all that over g squared. And g squared we just said was x cubed plus x squared. Now that we have that, this is our c prime. Notice it's extremely large. So what I'm going to do here is I'm going to rewrite it over here, and then we will go from there. So we say c prime is equal to 2x plus 5 times x cubed plus x minus x squared plus 5x minus 2. And you know what? I'm going to write it a little bit farther out so that we can see it a little better. So we have c prime equal to 2x plus 5 times x cubed plus x minus x squared plus 5x minus 2 all times 3x squared all divided by x cubed squared. So now we have all those terms. We said that f prime of x is equal to a prime plus b prime plus c prime. So we just add all of these together. So I'm going to kind of start here at the opposite end so that we have enough room. We have f prime of x is simply equal to 2x natural log of x minus x all over natural log of x squared, this was our a prime, plus b prime, which is 9 e to the x plus 9x e to the x, and then plus, I'm going to have to go down a little bit, that huge c prime term we just determined, plus 2x plus 5 times x cubed plus x minus x squared plus 5x minus 2 times 3x squared all divided by x cubed plus x squared. And this is our final answer. This would probably be a moderate, like I said, to a difficult example that someone may put on an exam. It'd be very good for you to try and practice this problem a couple of times just so you get the feel of it.